Hello, everyone, and welcome back to Topictrick. I'm glad you're here. If you are working with databases, specifically IBM DB2, you know that performance is everything. You can have the best hardware and the cleanest code, but if your database doesn't know how to find the data efficiently, your application is going to crawl. Today, we are deep diving into one of the most critical maintenance activities in the DB2 world, RUNSTATS. Whether you are a student just starting out, a fresher facing your first production environment, or a seasoned professional looking to refresh your knowledge on advanced parameters, this video is for you. By the end of this session, you won't just know the syntax, you'll understand the strategy behind statistics, how the optimizer thinks, and how to tune your command for massive enterprise tables. So, grab your notebook and let's master DB2 RUNSTATS. Let's start with the basics. What exactly is RUNSTATS? Think of the DB2 optimizer as the GPS navigation system of your database. When you run a SQL query, the optimizer has to decide the best route to get your data. Should it use an index? Should it scan the whole table? Which table should it join first? To make these decisions, the optimizer relies on a map. In DB2, that map is your catalog statistics. However, as you add, delete, or update data, that map becomes outdated. The roads change. If the map isn't updated, the GPS, your optimizer, might send your query down a slow, inefficient path. RUNSTATS is the command that updates that map. It scans your tables and indexes and records vital information into the system catalog tables. Here is what it actually collects. Table statistics. How many rows are in the table? How many pages does it occupy on the disk? Column statistics. How many distinct values are in a column? For example, a gender column might only have 2 or 3 values, while a transaction ID column has millions of unique values. This is called cardinality. Index statistics. How deep is the index tree? How scattered is the data? It stores all this information in key catalog views, like sycat.tables, sycat indexes, and sycat columns. The takeaway here is simple. Stale statistics lead to bad execution plans. If DB2 thinks a table has 0 rows because you haven't run stats, but it actually has 1,000,000 rows, it's going to choose a disastrous way to retrieve that data. Now, a common question I get is, how often should I run it? You might think, I'll just run it every night. That works for small systems, but in a real-world enterprise environment with terabytes of data, you need to be strategic. Here are the specific triggers for when you must run RUNSTATS. Trigger number 1, heavy data changes. If you have just performed a massive insert, update, or delete operation, say changing more than 10 to 20% of the table, you need to update the stats. Trigger number 2, after a reorg. This is crucial. When you run a reorg command to clean up fragmentation, the physical layout of the data changes completely. If you don't run stats immediately after a reorg, your indexes might not be used effectively. Trigger number 3, new objects. Did you just create a new index to speed up a query? The optimizer won't know that index is useful until you gather statistics on it. Always run stats after creating new indexes. Trigger number 4, high volatility tables. Some tables, like staging tables, go from empty to full and back to empty every day. For these, you need a strategy to capture stats when the table is populated, not when it's empty. All right, let's get our hands dirty with the syntax. The basic command is very simple. It looks like this: run stats on table schema dot table name. But as a professional, you rarely use just the basic command. You need to give the optimizer more detail. Let's look at the most important parameters. 1. On all columns. By default, DB2 might not look at every single column. Using on all columns ensures everything is measured. 2. With distribution. This is a game changer. Imagine you have a table of orders with a column for country. If 90% of your business is in the US and 10% is elsewhere, the data is skewed. Without distribution statistics, DB2 assumes the data is spread evenly. When you add with distribution, DB2 collects frequency and quantile stats. It learns that US is very common and adapts the plan accordingly. 3. And detailed indexes all. This tells DB2 to look deep into your index structure to understand clustering and leaf pages. So, putting it all together, a standard, robust production command often looks like this. Run stats on myschema.mytable with distribution and detailed indexes all. This command tells DB2, look at the table, look at the distribution of data values to catch skew, and look at all the indexes in detail. A quick warning, collecting distribution and detailed index stats takes more time and CPU. For massive tables, we have to use sampling, which we will discuss in the advanced section. Let's visualize this with a real-world scenario. Imagine you have a customer transaction table with 10 million rows. You have an index on the date column. Scenario A, the before state. You just loaded 5 million new records for the current month. You haven't run stats yet. You run a query, select star from transactions where date equals today. Because the stats are old, DB2 checks its map. The map says, hey, this table only has 100 rows. DB2 thinks it's faster to just read the whole table than to bother looking up the index. The result? A full table scan. It reads all 10 million rows just to find today's data. Your CPU spikes and the application hangs. Scenario B, the after state. You run stats on transactions and indexes all. Now DB2 looks at the map. The map says there are 10 million rows and the data is clustered nicely by date. The result? DB2 uses an index scan. It goes straight to today's records. The query finishes in milliseconds instead of minutes. That is the power of RunStats. It transforms a sluggish system into a high-performance machine. For those of you handling large enterprise databases, here are 3 advanced tips to take your skills to the next level. Tip number 1. Use sampling for large tables. If you have a table with 100 million rows, scanning every single row for statistics can take hours. You don't need to check every row to get a good average. Use the Tables Sample System option. For example, run stats on table, my table, table sample, system 10. This tells DB2 to only look at 10% of the pages. It's much faster and usually just as accurate for the optimizer. Tip number 2, statistics profiles. Did you know you can save your favorite RunStats options directly into the table definition? You can set a profile so that in the future you simply run stats on my table, use profile. This ensures consistency across your team. Everyone runs stats exactly the same way. Tip number 3, automatic maintenance. Modern DB2 versions have a feature called Automatic Statistics Collection. You can configure DB2 to monitor your tables and automatically run stats in the background during maintenance windows. While this is great, for your most critical high-volume tables, I still recommend running them manually or via a scheduled job to have full control over when that resource consumption happens. Let's quickly recap what we've learned today. RunStats is the GPS update for your database. The optimizer relies on these statistics to choose the fastest execution plan. You should run it after heavy data loads, deletes, reorgs, or index creations. Use options like with distribution to handle skewed data, but use sampling if your tables are massive. My advice to you, go to your test environment, create a table, load some data, run an explain plan, and see the cost. Then run stats and check the explain plan again. Seeing the cost drop is the best way to understand the impact. If you found this guide helpful, please hit that like button. It really helps the channel. And don't forget to subscribe to Topictrick for more deep dives into DB2, SQL, and database performance.